Hey everybody, it's Shane from Norman S. Wright. In this week's video, I'm going to answer the question, what is standard air? So let's get started. When you look at airflow performance data for HVAC equipment, you often see a note that says the data are based on standard air. But what does that mean, and is it important to you? Standard air is defined by ASHRAE as having a density of 0.075 pounds per cubic feet, a barometric pressure of 29.92 inches of mercury at sea level, and a dry bulb temperature of 70 degrees Fahrenheit. And it assumes dry air with no humidity. So let's move this up. So if you're operating a fan or a water coil at sea level, you're probably pretty close to using standard air. But if your conditions are very different, like at higher altitudes, or you're moving really hot air, the density changes, and your equipment performance can be way off from the cataloged data. For example, if your system's at 6,000 feet, the barometric pressure is closer to 24 inches of mercury. That reduces the air density, and your equipment performance can be off by as much as 40%. Fans may not deliver the cataloged airflow, and coils may not transfer the cataloged amount of heat. So now let's move this over and connect it back to the load equation. The load equation is Q equals 1.085 times CFM times delta T. You see 1.085 as a constant, but technically it's only constant for standard air. The load equation can be rewritten for any air as Q equals the density times the specific heat times 60 minutes per hour times CFM times delta T. At standard air condition, this works out to 0.075 times 0.241 times 60, which equals 1.085. So you can see here if the density changes, the 1.085 changes too. Luckily, you don't have to calculate the density every time. There are correction factor tables that you can use. For example, at 6,000 feet, the airflow correction factor is about 0.8, still assuming 70-degree dry air. So instead of using 1.085, you'd use 1.085 times 0.8, which equals 0.87. So this would make the load equation at 6,000 feet, Q equals 0.87 times CFM times delta T. Let's move this up. For most comfort cooling projects at or near sea level, this difference isn't big. But in high altitude places like Denver or Albuquerque, or in high temperature systems, it can make a big difference. So next time you see standard air in a catalog, remember it's just a baseline reference point. If your actual air is different because of altitude, temperature, or humidity, make sure you apply the correction factor so your system performs the way you expect. So let's bring all this back on. That answers the question, what is standard air? I'll go over how this specifically affects fans and water coils separately in a future video. If you have any questions or suggestions for future videos, put them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.